Okay, so on page 308, we have this first example, and of course what we're doing is we're solving systems of inequality still, and we're going to solve by graphing like we kind of started to do yesterday. So in this particular example, it says this. That's a pretty picture right there, nice boat and a nice lake there. It says a company makes two types of boats. Oh. On a different assembly line. Okay, so aluminum fishing boats and fiberglass bow riders. Okay, or bow riders maybe. It's a boat, bow maybe. When both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. All right, that's the first bit of information here. I'm going to highlight maximum 20 boats.
Mrs. Kramer, please call 205.
The demand for fiberglass boats is greater than the demand for aluminum boats. So the company makes at least 5 more fiberglass boats than aluminum boats. So at least 5 more fiberglass boats than aluminum boats each day. So as you already know, we're going to try and make two linear inequalities. We're going to graph them and find out what combinations of boats they could make that would fit this criteria. Okay? So this is what we're trying to do. Now the first thing you want to do always is you want to identify your variables. Identify and label your variables. So this is now where you can do this with me, okay? You don't have to copy out this, it's in your book, but so we want to take a look at the first and the second and the actual question here. So it says, what combinations of boats should the company make each day? So this gives you a hint. The question at the very end gives you a hint as to what the variables should represent. So it's not, what lakes are nearby. That has nothing to do with the question. It's definitely the two types of boats that are in the question. So we probably should make one variable about the one type of boat and the other variable about the other one. So why don't we say aluminum boats is A? Why don't we say that? Seems to make sense. A, aluminum. F, why don't we make F fiberglass boats? Okay. All right. And this would be the number of, I guess, right? The number of. Because that's really what we're talking about. The number of aluminum boats that they should make and the number of fiberglass. Okay. So that's first step. Identify your variables. That's what we're going to use. Now we start to look at the information that's given, and usually if there's two bits of information like this, each one represents an inequality. Okay? So the first one says, when both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. So a maximum of 20 boats, we're talking about aluminum fiberglass. Any ideas what the first inequality should be? This one's an easy one. Anybody want to shout it out? How can we make this first one into an inequality? Yeah.
Maybe A plus 5 equals F.
A plus 5 equals F. Well, I think that maybe you're thinking about the second one here. Let's take a look at this one. That one's not going to be A plus 5 equals F. And we want to do greater than or less than, right? Instead of equals. So that's the inequality part. Okay? So let's focus on this first one. A maximum of 20 can be made. How's that going to be represented? Okay, so the total number of boats are going to be A plus F. Okay, I heard this. A plus F has got to be what? Thank you. Less than or equal to 20. Okay? All right? I hope you're just tired this morning and not really into class yet. Actually, I just said I hope you're not in class yet, right? I hope you're not into class yet, as opposed to having no idea what we're doing here, because that is, you have to know, that first one is easy, okay? That first one is very, very easy. Everybody needs to be able to pick that out of the question, okay? All right, so the second one, okay. The second one, let's focus on this one now. The demand is greater for fiberglass boats. So there's at least 5 more fiberglass boats than aluminum boats. Okay? At least 5 more. So if we were to make an equation, if it was to be an equation, we would have to have 5 more what? Fiberglass boats than aluminum. So we would have to take the one that you're making fewer of and add 5 to it to equal the larger amount. Okay? So this is the tricky part. The first one was easy. This one is a bit tricky. Because if we're talking about an inequality, sometimes it's easier to think about it as an equation and then go from there. So that's what probably I would suggest that you do here. So at least 5 more fiberglass boats than aluminum. If we were to make an equation, okay, and I'm just going to start an equation here, and then we'll change it into an inequality in a second. We would have to have aluminum boats they're going to make less aluminum boats, correct? So aluminum boats, how would that be equal to the fiberglass boats? Well, if we added 5 to the fewer number of boats, then they would be equal. Okay? Now we need to change this to an inequality because it says at least 5 more. Okay? So is this going to be less than or equal to or greater than or equal to? That's the tricky part here. Okay? So any thoughts? Okay, so I heard a greater than. What were you going to say?
Less than.
Okay, do you know why?
Because it's a plus 5 is at least. So it can still be more than that.
Okay, so a plus 5 would be the minimum. We can still have more than 5 fiberglass boats. That's the thought. Okay, so aluminum plus 5 would be at least. Okay, so that means that the fiberglass boats, because there's so much demand, fiberglass is going to be equal to a plus 5, or fiberglass is going to be greater than. Okay, and it's usually the second one, guys, that's the bit of a trickier one. Okay, and you're going to have questions like at least twice as many of these than these, or stuff like this. So you got to get this, you got to work this through, get this figured out. Okay, so again, at least 5 more fiberglass boats. So the number of fiberglass boats has to be a plus 5 at minimum. It can be more. Good? Okay, so that's our two equations, inequalities. And now we're going to graph those. Okay, so let's work on graphing those. So you want to make you want to put a graph in your paper here. Just put a coordinate plane here. All right. You could probably just focus on quadrant 1, right? Because we do have restrictions, right? So A has to be greater than or equal to 0. Can't have a negative number of boats being made, right? And F has to be greater than or equal to 0. So really, we are just focused on quadrant 1 over here, right? We're focused on this right here. So having said all that, you could, instead of making a coordinate plane like that, you could just do, I guess, one sort of like this, right? Knowing that we don't have any negatives involved. Okay. All right. So A plus F equals 20. Let's find out where the boundary is for number 1. A plus F equals 20. Okay? So the points that we're going to have are going to be 20 and 0. That's going to be 1 point, right? 20 and 0. We're also going to have 0 and 20. Those are the two intercepts. Okay? We're going to have 10 and 10. Right? We're going to have 15 and 5 and so on. So you see how this is forming this line, 5 and 15 and so on. So I'll make a line here. And try and fit those through all those points. Okay? Whoa, that didn't move. There we go. Okay, so there's the first boundary line. Now it's equal to, so we can make it solid, right? Are we going to shade, or what would be the region here? Would it be above or below? Again, let's pick 0, 0 and just see if that works, right? Remember that? 0, 0 is always a good one to pick. If the line doesn't go through 0, 0, then that's a good one to pick. So 0 plus 0 is less than 20. Does that make sense? Yeah, okay. So we're talking about a region that is underneath the line here. And remember, I just do these arrows because if you have a system of equations with 4 or 5 inequalities, which we're going to come up against later, you don't want to be shading things 3, 4, and 5 times. That it kind of gets lost. So I just use those arrows. All right, so that's the first one. Okay, second one. This one here. A plus 5 equals, A plus F. A plus 5 equals F. I guess we should state which one is A and which one is F. Let's do A over here, F over here, guys, okay? Or A and the F axis, okay? aluminum down here. So this is y equals a plus x plus f, right? That's really what this is. So if we go, so I'm going to write that like this. This is y, and this is the x, and I put f for 5 again. Okay, so that's kind of like what I'm saying is that this is actually like this, right? If you're thinking about a line here, as f is y and a is x. So this line right here has an intercept of 5. So let's put that, let's see, here's 10, here's 5. And a slope of positive 1. Okay, so we can go up 5 and over 5. Up 5 and over 5. 10, 15. Okay, so you can make a line like that. So let's do that. All right. Now, if you have graph paper, that's the best way to do this, because then you can see where your lines are, right? Obviously, graph paper is going to be awesome. So if you have graph paper, you can do this. Perfect. You guys at least have lined paper. I don't here. But anyway, so it looks like we're going to have an intersection point here, right, over here. So that might be important. So let's figure out which region above or below the line should be shaded. Any ideas? Can we try 0, 0 again here for this one? 5 is less than 0. Does that make sense? 5 less than 0? No, that doesn't make sense. So that means that 0 is not in the solution region for this one. So it's going to be arrows above. Okay? Everyone see that so far? Okay. So it looks like the overlapping region is going to be here. This is going to be your overlapping region. That's the feasible region right there. So any combinations of boats in this region will work. Okay? Okay. So the question actually says, what combinations of boats should the company make each day? Okay? So there would be a number of answers, because it just says how many boats satisfy the criteria, right? So what number do you think is going to go in here? What's a number that's going to go in here? Well, if you had graph paper and you drew things a little bit more exact than I did, then you would be able to see, well, we could make 5 aluminum boats, and then we could probably make 15 of the fiberglass boats. Would that work? 5 and 15 is equal to 20. Okay, so actually that's going to be on this line over here, and that should work for this one too. 5 plus 5 is 10. That's less than 15, so that works. So 5 aluminum, 15 fiberglass. That works. Okay, so there's one, and you would have many. Is it possible to find out what this intersection point is? Does anyone know if that's, you guys ever, you think you might know how to do that? Because that's going to be important to be able to do. Anybody, any ideas? We want to find a point that works for both. We could do trial and error, I suppose, right? But let me just show you this. This is pretty important. It's going to be important coming up here. If you want to find the intersection point there, because that's going to be a pretty important point to know, then what you could do is, again, these two lines here, you're trying to find the x value where the y values are equal, right? So the x and y values are equal. So if you let each equation, and again we're talking about the line, if you let those equal each other, then you can find out the point. So what we're going to do is we're going to say this one is, let's solve for f. Okay, so f would equal 20 minus a, right, for this one. That's the equation with f being solved for. And this one, f equals a plus 5. Okay? So those are the two equations of the red lines. And if we let them equal each other, so f and f, if we let these equal each other, then we could find the intersection point. So 20 minus a equals a plus 5. Okay? And this will give us the a value right here, a value, that will represent the point of intersection. So you do have to know how to do this kind of by hand here, but I will show you with the graphing calculator a little bit later how to do this as well. So if you add a to both sides, you get 2a over here. If you subtract 5 from both sides, you get 15 over here, I guess. And so a is going to equal 7.5. So this doesn't equal a positive or a whole number, right? Which, again, you know, if we're talking about our feasible region, we shaded this, but really we only should be considering whole numbers of boats, right? It doesn't make sense to make a partial number of boats. So this point right here is not going to be a possible solution because we have a is 7.5, right? And so f is going to be whatever 20 minus 7.5 is going to be, which f is going to be 12.5. Okay. So that's the intersection point. It's not a whole it's not whole numbers, so we don't worry about that intersection point. So we're trying to find points that would be inside this feasible region somewhere. Okay? Any questions about that? Yes. So if we went back and did this even more accurately, this line here would be dotted because of the nature of the domain and range, right? Okay? So just so you know, that's why this is not included, because this intersection point wouldn't be one of the whole number options. So the whole number options would have to be inside here. Okay? So both these lines technically would be only where there's whole number combinations. Those are the possible solutions there. Okay?
Oh, right.
Any other questions?